We then have an introduce the team, and it's Open Data Visio. And you will say a few words about the team or introduce the team. Thank you.
Hello everyone, my name is Miranda and I'm one of the four mentors in this challenge. So in this challenge we have four mentors and one mentee. I hope she will not overwhelming to all of us, but yeah. So our challenge was our challenges is in a few months will be open data. So in a few months, all the data will become open, and we we want to prepare for this, and information about our data, especially about this open with our data, is a little bit all over the place. So some information is in one place, some information is in other place. So we were thinking what could be somehow gather most important this information in one place, and examples of how to get this data from the when it lives on the web or through the API, and how can we gather all of this information in one place and give users some examples of how to do this. This is, and for this, Alenka made a nice Jupyter book, but our like a secret um, um, thing that we wanted to get out of this is to observe both somebody who never used our open data, uh, how they are looking for the data, what challenges they face, how they overcome, what help do they need, because this is something that we will need in a couple of months. So yes, Alenka did a nice job, and she will now present her work.
So you can scan a QR code, and during my presentation have a look at the tutorials which represent the main deliverables of this project and get engaged in it at your own pace. And also tutorials offer more information and case studies that I'm going to share with you today. So I represent you this one-stop shop Open Data VISIO, which will provide you with tools to explore ECMWF open data as well as guidance. Everything was actually already out there. I only put together in Logic Turbo. But before I start, I would like to thank my mentors for their support and feedback on my work during the coding phase. Some logical data, especially real-time weather forecast data, arouse considerable interest in many different sectors. And there is no all-in-one solution where one could find the requested information, how to process ECMWF open data. So users spend more time to analyze open data. The main objectives of this challenge were to improve fundability, accessibility, interoperability, and reusability of ECMWF open data. In these tutorials, we'll enable users from scientific and user communities to have access to the state-of-the-art tools and also assist them to extract general information from the vast areas of forecast data and to integrate it into their workflows. Here is a brief outline of the topics that I'm going to cover in this presentation. I will use kind of a top-down approach. First, we will dive into different case studies. Then I will share my experience of using EarthKit, ECMWF open data package, and accessing open data. And in the end, I will also present the tools that I use to do this project. So it's move.
I think you're clicking twice.
Okay. Yep. Okay. So here you can see to real-time forecasts from IFS single data sets. One shows 10-meter wind speed in direction over Europe, and the other 2-meter temperature over the next 7 days using the latest forecast data, but the presentation was prepared in the last week, so they are not actually the latest forecast data. The first graph was generated using Earthscape plots package, and I use Hintflex and barbs. And this package can automatically detect as well as extract U and V components, but you can also provide those as arguments. And then the second graph, I manually defined stars, some colors and levels, but it's also possible to assign configure stars to your database on the metadata. In the end of April 2025, the Western European countries experienced unseasonable warm weather, and the first plot demonstrates geopotential height and temperature parameters in Europe on 28th of April at 500 and 850 hectopascal, and geopotential heights contours indicate that all France was a high was a strong anticyclonic system which lasted several days, excuse me. And in case of geopotential, on 500 Pascal, a new field list with a single field containing the new values and metadata was created because I calculated the geopotential height from geopotential. And for single field list, one has to use the bracket operator to catch the first element from a list and access as well as modify its meta. And in the second two graphs, analysis of maximum and minimum temperature at 2 meters in the last 3 hours of the IFS datasets over France on 30th of April is shown. And I can see a strong a sign of a heat island over Paris and London. Then the next case study, winter storms had a tremendous impact on Sweden during the first week of January. A low pressure system impacted various parts of northwestern Europe with strong winds and heavy snowfall. The plots on your left-hand side depict precipitation of 4 consecutive days, and this are not accumulated. The plot total precipitation between steps 12 and 24. We needed data on both time steps and then subtracted the precipitation on step 24 from the step 12. Otherwise, total precipitation gives information about total accumulated rainfall from the start of the forecast onwards. In the plot on your right-hand side shows analysis of 10-meter wind gusts of at least 15 meters per second over southern Scandinavia on the 7th of January. And we can see that it's very likely that the 10-meter wind gusts along the North Sea and Baltic Sea coast, and it also exceeded 15 meters per second. The Earthscape package is in development and subject to ECMWI guidance on software maturity. So additional features will be added in the future. But here I will present some benefits and challenges that user might face. The great benefit of using the EarthKit package is that it simplifies data access and analysis and visualization. It's high-level, scalable, and compatible package built on top of other Python packages. But to break down some challenges a user might face while using it, errors occur when we use the stream and facts option. For instance, when do want to specify the parts option, when we don't specify the part option and want to convert our result to X-ray data sets, we receive the error message, something like from Amazon AWS and ECMWF data store. And it's also possible to retrieve data from multiple models, parameters, and dates. To download data from multiple models, you can only list IFS and AIFS single models, and then filter the data based on the criteria you specify. And then similarly, to download the data for more than just one day, you can list all dates and then filter out the data based on the criteria you specify. And to point out some difficulties when retrieving historical data, it's important to keep in mind file naming convention. So here you can see in magenta and red colors changes in resolution and the availability of models. To give one example, products produced at 0.4 degrees were retired at the beginning of this year, and now the 0.25 degree resolution data are available. And in addition, it's not possible to download data from Microsoft Azure storage because Microsoft Azure has changed the anonymous function to ECMWF open data, and you can access them using their Python client package. ECMWF is transitioning to fully open data policy, making weather forecast data more accessible to various sectors. This includes data from both integrated forecasting system and the artificial intelligence forecasting system. The move aims to facilitate wider use of high quality and American weather prediction products across diverse fields, aligning with the broader trends and initiatives promoting open access to meteorological information. The data is provided at the highest available resolution and are released under a Creative Commons Attribution 4.0 international license, allowing for commercial, non-commercial use with proper attribution. And data is available soon after its production, with some data sets released with minimal delay. And also some benefits and challenges on this topic. The huge advantage is the availability of vast array of parameters of ECMWF open data from different locations. And some obstacles that user might come across are the file naming convention was changed, which means a user must use different Python packages to retrieve datasets from different data providers, and not all AIFS and AIF ensemble parameters are open to the public. How ECMWF open data impacts different sectors, I will present only some of them. So on disaster risk reduction, open data allows for better preparation and response to extreme weather events, supporting initiatives like early warnings for all to ensure universal protection from hazardous hydrometeorological, climatological, and related environmental events through life-saving early warning systems and resilience efforts. Then on research and development, researchers across various disciplines and operational meteorologists can leverage the data for studies in meteorology, climate science, and other related fields. And on renewable energy, open data on wind and solar resources can be used to optimize the placement and operation of renewable energy infrastructure. So where you can find ECMWF open data, they are available from ECMWF Data Store, which offers datasets from current date and up to 4 days before today. Data can be retrieved in different ways using EarthKit, ECMWF Open Data, and request packages, wget, and curl. Then from Amazon's AWS S3 buckets, which holds data from 2023 until today. And it's important to bear in mind the file naming convention, as she mentioned. And mostly in the case studies, I retrieve the data from AWS S3 buckets. In Microsoft Planetary Computer makes the ECMWF products available for the previous 30 days. However, Microsoft Azure has changed the anonymous function to the ECMWF Open Data, and one cannot download the data using ECMWF Open Data package because actual data assets are stored in private Azure Blob storage containers. Alternative, one can use the Python client library, and after creating a client, user can automatically modify the spatio-temporal asset catalogs objects returned by their API and download the data assets. Then a shared access signature token granting access to the file is included in the URL. And the last one is OpenMeteor with an open source ladder API. One can access forecast data for up to 16 days or historical data from 2017 onwards. It's possible to choose non-commercial, commercial, or self-hosted license. For non-commercial license, less than 10,000 daily API calls are available. And it's also important to bear in mind that the user has to specify the exact coordinates and time interval when retrieving the data. So for this project, I used the following tools: Jupyter to create Jupyter book in Python with EarthKit, ECMWF, Open Data, Python client, Planetary Computer, and OpenMeteor requests libraries, as well as other packages. So if anyone has QR code, they can also see these tutorials. So Jupyter notebooks are structured in the following order. Quest, a user must set up the environment and then define parameters to retrieve the data from open datasets, so which parameters they wish to retrieve. Then use the ECMWF Open Data API, manipulate the data, and at the end plot the data. And the tutorials provide you with useful tips on efficient data download using programmatic methods and other approaches for optimal retrieval of continuously updating real-time data. And what's more, the main parts of lessons learned about what challenges a user can be faced with while analyzing open data. And then to conclude, Open Data Explorer tutorials include a rich amount of case studies of different weather situations and best practices in processing and plotting open data. Open data are available from IFS and AIFS models and on different locations. The EarthKit and DCMWF Open Data Package are powerful tools for speeding up weather and climate science workflows and future work. Open seasonal products will provide information about atmospheric and oceanic conditions for 1 or more months into the future, but they are not available yet, but they will be soon. And additional case studies can offer insights into the development of the EarthKit package and support data analysis projects among scientific, commercial, and operational users. And thank you.
Thank you very much, Alenka. Who of you have used open data from ECMWF? Okay. What is your experience? Just mentioning.
I would certainly try the not this simpler units.
Okay. So generally, was it difficult to find all the old data?
Or with the handbook mentors, it was easier, but just to be thrown and try to find something by myself, it would be
Okay. Let's- Any questions? No? Good. Then another optic across on.